Mic testing 1, 2, 3. Okay, just now, still back to our question on acceleration. The positive sign and negative sign, the previous slides. What I mean by positive and negative sign? Positive sign means it's getting faster and faster, means that your V2 is higher than your V1. Make sense? What I mean by negative value? Means you slow down. Your velocity slow down. Means your V2 is lower value than your V1. Okay, so the red box there is actually incorrect, but you can still take it as it's still right in the certain sense, but a more general one is that positive means it's getting faster and faster in that particular direction. In this case, straight line, if you to the right is positive, means it's getting faster and faster to the right. If you get negative, means it's getting slower and slower to the right. Okay. Next, we start to derive 3 more equations. I name it in my class as Newton motion equation. Okay. Now, just now, our instantaneous velocity ds over dt, instantaneous acceleration a equal to dv dt. So can we group these 2 definitions into one single equation to help us to solve equation? Means that if you want to, the word instantaneous means that we press the pause button in the video, right? So we take out the t element, meaning we can write these 2 equations in terms of that particular free zone. So we can rewrite this equation. We pull the dt to the left, put the v bottom. This one pull to the left, a put bottom. You have dt equal to ds dt dv, dt equal to dv dA. Mathematics, you know that this one equal this one, and you have the same notation. dt means this one is the same, means you pause at the same time. This one equal to this one. Make sense? Mathematically, makes sense, right? So normally we don't like this one because it's a ratio. Normally we write in the linear form, meaning we move a to the left, move v to the right, we get a linear form. This is a fraction form. So we arrive at a ds v dv. So first equation, after we derive this one, these 2, we get a ds equal to v dv. How we get this one? We freeze the time. Okay, I didn't bring the. Okay, 1 minute now. We will use this equation to further expand into motion equation where you are familiar in your physics class. It's very useful later in chapter 2, chapter 3, and so on. We will always recall this one. So this slide recall the previous slides. We continue, right? So we know that we can write a equal to dv dt, and just now a equal to dv dt, we can write we can pull the dt to the left. We get dv equal to a dt. When you study your maths, every time you see something d something equal to something dt, the next steps automatic put in the integration sign, meaning you are going to do integration steps. This is automatic one. Every time you solve question, you write something that d something one side, d something one side. Next step, you're expected to do integration. So you see in the slide, sir. So this one, you put in integration sign, integration sign. So you integrate from original v0 to velocity of interest, dv equal to integrate t equals 0 to the time, and AC means constant acceleration dt. Only for chapter 1 and chapter 2, the rest you will see t not necessarily equal to 0. This is because in chapter 1, everything will be simplified for you. V also, in later chapter, you won't see v starting v equal to 0. Huh? So this is just a demonstration. So recall your, do I need to give you revision on the integration steps? No need lah. Okay. So this one, you integrate, you substitute the value. This is 1, so you get v minus vo. V minus vo, you get left side. This one, AC, you bracket, you substitute t minus at0. You get ACT, left hand side. You move VO to the right hand side, you arrive at this equation. This is the first motion equation. V equal to V naught plus ACT. C means constant acceleration. It depends on question. It depends on question. Sometimes you need, sometimes you don't need. Because sometimes you need to, like example just now, I give you the S equation. So from S equation, you find this one. Then from this one, you do this one. It depends on question, right? Normally, it depends. Normally, no lah. Probably no, but you have to know when to apply it. Okay, so this one is the first motion equation. Pay attention to the A. A is a constant. First equation for the second half. Next one, I think this one you learn in your physics also. Second one, we take the V equal to dSdt, means we focus on the velocity. We take displacement divided by the change of time. And then same procedure. The ds you hold, dt you move to the left, means v dt. So you get a linear form, ds equal to dv dt. Again, same, every time you see dt one side, dt another side, you go ahead and with the integration procedure. So you have s one side, v one side. However, when you integrate, sometimes you need to be careful. This is v. Inside v, there's a t there. So be careful not to stop here. Some of you, when it comes to final exam, you forget these slides. You will straight away do differentiation. You will get vt plus a minus 0. We give you the wrong answer because when it comes to final exam, your t here is not 0. Take note, this is a student mistakes every time come to final exam. They want to solve the question very fast. They forget that v actually means something. V is a vector. Vector means you have magnitude and direction. So when you have a direction, you have a magnitude, it's something linked with the time, right? So different time, different value. So it's not necessarily 0. So if you integrate from here, this one, you will not see the zero, the starting point time here. Okay, so what you do, remember, V have a definition. So we already derived the equation just now. V equal to V naught plus ACT means that your equation actually, there is the time terms inside here. Make sense? Yeah. Substitute this one inside here. Do continue with the integration steps. This side, you get S minus S0 integration steps. This one, you have two terms to integrate. This side, you get Vt minus Vo multiplied by 0, first term. Second one, you have ACT integrate dt, this one, t power n plus 1 divided by n plus 1. So this one, t become 2 divided by 2. Correct? Anyone need me to write the steps? No need, huh? These are integration steps. Okay, huh? Okay, stop me if you cannot. Let me, I can write the step for you. You'll get this equation. All right, you'll get S minus S0 plus V ut plus half ACT squared. Second equation, sometimes this one I write as delta S, just to memorize. Huh? Okay, so first equation, second equation. Third equation, recall that just now we have one extra equation to memorize, which is A ds equal to V dV. Now we use this equation to derive the third equation as a function of time. So on the left hand side, this one also the different d something. So use this equation to integrate in the function of time. So again, don't straight away go and integrate. Okay, so here S something, V something. So in this case, because we want to put, you can further substitute the V definition, but this one we want to hold the V because sometimes you have the V and you can straight away use the equation. So here, this one we do not substitute because we want to remain the velocity. Our focus is focused on velocity. Okay, for this case, because we already dV already. Here we already dV. So you integrate V, so you don't need to substitute. Just now you don't have the time there. That's why we need to expand it. Understand? Yeah. So this is dV, yeah. So you integrate V, you don't need to further expand anymore. Just now the previous one, because in the V, you integrate towards time. That's why you need to expand. So at the end, you arrive at this one. This is the third one. Third equation, V square equal to V naught square plus 2AC S minus S0 or delta S. For chapter 1, these three equations, be careful. These three, the A acceleration here, they are constant. Huh? If your question, you found that the acceleration is not constant, then don't use these three. How you know that your acceleration is a constant and not constant? If your u equal to a e plus something, meaning your acceleration is not constant. Because the time change, velocity change, velocity change, acceleration change. Make sense? Okay, be careful. Huh? So this one, you have to be careful during these three equations. So not yet conclude lah, but the one that you see on the whiteboard here, they are actually the most used equation to solve chapter 1 question. So you memorize these three, memorize this one, this one, this one, this one. 4 equations, 7 equations. Okay. Once you understand these 7, you can solve most of the question from chapter 1. Let's solve question now, tutorial question. Again, this question you won't see in your test 1, test 2, or final exam. It's too simple, but it's to guide you how you apply what you learn just now. So you have a car move on the left, move to the right in a straight line. Chapter 1, if you see straight line in the question, it fall under chapter 1 question. Right? Because it's a rectilinear motion. So define by velocity v equal to something, an equation. T in second, determine the position and acceleration at the time of 3 seconds, and it gives you the preliminary or early definition when it's time 0, displacement is 0. So on the diagram, you draw a straight line, label initial position. Of course, in exam, you don't need to draw as pretty as what you see. You can denote as 1 point. Just one cycle, note that. Okay. So we move to the right. There is a displacement there. Or there is a position change there. Right? So it gives you, and you need to find the SV. So initially, this is the S. This is the S prime. Sorry. So S, this here, O here is the S. And then this one is the S point. Okay, so my slide is just to show you what is the value there. So coordinate system in your diagram, always tell the evaluator where is positive, right? Where is positive? So to the right is positive. So what information given? V is given in the equation in terms of time. So you know this one, when you V is in terms of time, the 3 motion equation over there cannot be used. Don't act smart. Go and I don't need to derive equation already. Straight away use this one. Wrong. Because acceleration change. This 3 must have constant acceleration. Okay. First, you find the position, right? Position. V equal to ds dt. So from these 4 equations here, you find which one is the position. Here you got one position, as here you also have position. So you can either use this one or this one, but you want to find the position first. You are given velocity. You have a differential equation. You know that from differential equation, you can use integration to find the parameter you want. You move the dt to the left, v dt equal to ds. You integrate, you get your position. Make sense? You rewrite the definition of velocity. V equal to ds dt. You rewrite by pulling dt to the left. Restructure it. You get ds over dv dt. You know that you see this form. The next step is integration steps. This is where I answer your question. When we need to derive the equation. This is the place where we need to derive. Okay, the rest is integration. Right? So you substitute lah. Again, if you have v dt, don't straight away differentiate or integrate the v, because you are looking at time and not velocity. This one. You see this one? Remember to change this one in terms of what you want to do. This one you focus on time. So you substitute whatever equation given, because this one exam will change. So make sure you polish up your integration or differentiation skill. You integrate. I just put one there just to highlight that there is a value there, because some students, they will assume somehow in a final exam, they will automatically assume 0 here. I don't know how. Some students, they will put 0 here. Means 0 on the left-hand side. Wrong, huh? So there's a 1 in front of ds. So you integrate. So left-hand side is s minus 0. If you integrate, left-hand side s minus 0. Right-hand side is the integration. So the n here plus 1 divided by the n plus 1. So t power 3 divided by 3. This one t power 1 plus 1 t power 2 divided by 2. You'll get this equation. Make sense to you? Is the set make sense to you? Yeah. Then you substitute the value, right? You substitute value, you arrive at one equation. S equal to something in the unit of meter. For this module, every time the answer will have magnitude and unit. So let's say this is the answer. Let's say magnitude is 10 meter per second. If this is 2 mark, if you only write 10, you'll get 1 mark, because you miss out the unit. Okay, this is 50% of the marks, 50% of the marks. So if this is 4, this 2 mark, 2 mark. So if you lazy to write unit in your answer, then you might lose a lot of marks. You have to give this one first. This one got mark 1. Why? You can skip this one. Then you substitute 3. Sometimes you don't know lah. In final, sometimes your finger do funny things one. You press, then come out the answer wrong one. Because the button very small. Sometimes you press. Maybe you want to press 3, but you press maybe 6. You press the one that above it. Then you don't know, you kanchong. Then you write answer, then wrong. Okay, so this one is to secure your mark. Okay, T, then you substitute. Okay, substitute 3. Okay, how do I give marks every time? You write this one. You can skip here, but this one is a must. You can skip how you do integration, but I'm looking for the result of integration to get this one. This one must read, must give. There's a point there. Normally, at least 1 mark here. This one, calculation, normally 1 to 2 marks. So this one, if you show how you calculate, it will be marks there. Same with your assignment, yeah. So in your assignment, some slide, I do not give you the detailed calculation. I will just give a wording here, substitute, and then I give you the final answer. So when you pass up your assignment, make sure you substitute the value and do as you're working for your assignment. Okay. Any question for this one? You apply the same to find the acceleration. Okay. Now acceleration, once you already have the V, recall the definition of acceleration, you can straight away use A dv dt, or the equation just now. In the answer, you have the S, right? You have the S equation, or you have the V equation also can. You can prove your answer. Either way, we'll get the same answer. So the second part actually asks you to apply acceleration definition, where A equal to dv over dt, do the same procedure, rearrange, integrate, you get the answer. Right? A equal to dv dt, rearrange, A equal to the A dt, do differentiation. Right? A equal to this is differentiation scale. 2 move to the front. 2 minus 1, you get 1. So that's why there's a 2 there. T and t power 1 minus 1, 0. T0 is 1. T power 0 is 1. Then only you substitute the time there. Remember the unit acceleration is meter over second square. When you do this one, you can skip the unit, but when you give the answer, I will look for a unit. Okay. The answer is 4.6. Which one? You mean this one? These steps you sometimes I don't look into it, but you can write lah. Important is this one. How from here reach this one, but you must write this one. This is important. If you don't write this one, you don't write this one, suddenly give me this one, then there's question mark. How you get this one? Are you copying or you cheating or something? So this definition is important. So that's why I always remind you, when you solve question, give general equation first. This one, this one, this one, this one, this one, these three will cost you 7 marks already if you write the correct one. These are free 7 marks here. Of course, it won't appear in the same question, but these are the free marks here. Okay. Again, I highlight in my notes there why the 3 equation of motion cannot be used, because acceleration is not constant. Although sometimes you get the same answer. All right. When you get the same answer when the starting point is 0, everything is 0, then you'll get the same answer. But if the starting point is not 0, then you get a different answer. Okay, let's look at second application. Let's say you have ballistics test. This one is in your tutorial question 17. You have a bullet that you shoot down, right? You shoot down in the water. Velocity, initial velocity is 60 meters per second. Now the starting velocity is not 0 anymore. Now the starting is 60 meters per second. Due to drag resistance, fluid projectile experiment, the acceleration A is given here. Of course, this is very friendly question. In final, I won't use the acceleration for you. I will give you A equal to negative something. Then you know this is deceleration. All right. So sometime I will just give you a scenario, the acceleration decelerate. But then in your answer you have to give negative value. Either one. Either one. So here both appeared just to help you to understand. Determine projectile velocity and position after 4 seconds. So again, here the acceleration change also. So the acceleration here, again, it asks you to apply the definition on the whiteboard there. So it asks you to find velocity, you're given acceleration. Go and define acceleration first. Acceleration equal to dv dt. Then you do rearrangement, you do integration. Same. First step, pull out the equation. Look at the equation form. rearrange it. Either is differentiate or integrate, it depends on the form. So, coordinate system, in this case, is not to the right positive, but go down is positive. Be consistent with the thing. So this one you shoot down. So as long as it's along your position or motion, then it's positive. So velocity, how we find? Acceleration is given. Initial velocity also given. So what you have? You have VO. So recall, acceleration definition, A equal to dv dt. Again, this is instantaneous acceleration, means you pause the things. It's not the average velocity, average acceleration. It's an instantaneous acceleration. So A equal to D something, but answer question give you minus 0.4 V cube. So actually, it's testing your understanding in acceleration definition. A equal to dv dt equal to what? From here, you can find the velocity. So pull the dt to the left, to the right. You see d on the left-hand side, d on the right-hand side. You know next step is integration already. However, this is v, right? This is t, right? So don't go and straight away do. It must be pair the same. You must have t here. Then you only can move on. On the left-hand side is v, right? Always you pack the same thing together. Pull this one to the left. So that your left, you'll see v. Right-hand side, you see t. This is mathematics. Okay, careless mistake happen from here. It's not that you don't understand, you understand, but you jam at your mathematics skill. Okay, pull your v to another side. This is divide. Why divide? Because this one is multiply. This one multiply. So when you multiply, move from change the position, become divide already. Anyone don't understand why this one divide? Can stop me if you don't understand anything on the screen here. You know something divided by something and d something, or you integrate, you'll get ln something. You integrate dv some left hand side, dt one side, the next step is integrate. Remember there is a 1 in front of empty space here. Again, when it comes to final exam, some of you panic. You will see this one as 0. Automatic, I don't know, somehow your hand will write 0 here. Because later on, you'll see a lot of equilibrium, then automatic, you'll write 0 here. Okay, be careful. This is, you have a 1 there. The rest is integration steps. Again, when you integrate, limit, be careful on the limit, it's not 0. It gives you the initial velocity 60 already. Substitute 60 on the lower limit of your integration. V is what you want to find. T, it gives you t 0. Right? Then the time of what you want to find. So you pull my step, I pull the constant out first because I don't want to confuse myself. I pull all the constant out outside the integration steps. That's why you see negative 0.4 outside the integration. So 1 over something, you'll get minus. 1 over something minus. You change the power to minus. This is exponential format from friction to exponential format. 1 over something, there's a negative there. Then you continue substitute accordingly. All right, again, there's a negative. When you do the integration, minus 3 plus 1 divided by minus 2. Minus 3 plus 1, you get minus 2, divide by n plus 1. That's why there is a minus 2 there. Okay. You arrive at one equation. Do da da da. Okay. Da da da. You will get rearrange, rearrange until you get v equal to something. This is the expected answer. V equal to one equation. Okay. Yeah. Which one? Too fast. All this you try to understand the step first. You don't copy and then you don't understand. Important, what are the steps that we're using? And then some of you might weak in integration, that then you go home and polish it up. Right? And what are the possible error that you might go into? Sometimes is this one negative, sometimes you forget. Yeah, okay. Yeah. Be careful also this area. Sometimes when you minus, sometimes your initial is negative value one. Sometimes in final, your initial will be negative. So negative, it become positive. That one is final lah. But in this example is as shown on the screen here. All right. Okay. Then you get the final equation for v equal to something. Then from here, he asks you to determine the velocity after 4 seconds. So you have a time here. Substitute t equal to 4. Then you get one answer. Okay. Again, this is 1 over square root. 1 over square root, what does it mean? When you have a square root, you have positive and negative value. Make sense? So, but velocity here, we will take positive. Why? Because it's going down. Of course, there is a, if you want to find, there is a negative value also, but the bullet won't reverse back, right? So that's why you put the negative value there. Yeah, take note. When there's a square root, there is a positive and negative value. In this case, we choose positive because bullet is going down. Okay. Next steps, position. You also find velocity position, right? But too fast. Too fast. Don't worry, you'll get slides later. I will upload slide on the canvas. You don't need like, wow, copy. How to understand what's happening there. Okay. Next, we find the position is S. You have the A definition, A dv dt. You just now you derive from section A, which is a velocity equation. That means if this one wrong already, then position also wrong. Then you know that V equal to ds dt. You know that V definition equal to displacement divided differentiate by time. Do the same. If rearrange and then see you want to find position, then integrate. Okay, you rearrange, pull the ds one side, dt one side, and then check again before you move forward. Left hand side is about s, about displacement. Right hand side is about time. So you check inside here, bracket here. Is there any alien parameter here? No, everything is good. T here. So then you can proceed. Okay, so like example 1 just now. There's no T here or V here. Then you need to change this one, or you need to look at another side whether there's any same parameter or not. Okay. Then you do integration, blah, 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 substitute. Okay. It's a lengthy mathematics steps. Normally your test one will test your differentiation skill and integration skill. You will test your understanding in the velocity definition, acceleration definition, and then play around with the differentiation and integration. Okay. This one you can get from my slides, huh? Substitute, you get one answer. It's a lengthy equation. Answer is 4.43 meter. For this module, minimum 2 decimal place, maximum 3 decimal place. One more? Or you want to read yourself this one? We go another topic. Huh? Read yourself, huh? Can? You can? Can, huh? I'm okay one. Okay, read yourself, huh? This one a bit tricky one. This one go up and go down one. Go read, huh? Yeah, skip. This one go up, go down. We use the equation on the whiteboard there. Yeah. Huh? In my slides, you say don't need ma, so read lah. It's inside here. Everything is there. You see, I derive. Oh, okay lah. I explain this one lah. Okay, I explain this one. Then we call it a day. Okay. So this one is normally this question will come in your final, right? So of course this one already show you already. You won't see rocket question, but you'll see somebody throwing balls or throwing bricks or some projectile question. But the concept still same. So during a task, rocket travel upwards. So we travel upwards. Okay, during exam, sometimes the diagram won't be given. You need to interpret the question based on your understanding. So normally you will see rocket like this in the question only. Then you need to draw yourself. What do you understand about the question? So the test rocket travel upwards a certain speed, a certain velocity. When it reached 40 meters from the ground, engine failed. Engine failed. Determine the maximum height that this rocket can reach and its speed just before the ground. There are two questions here. One, although engine failed, this one will continue to move until no more power. Means velocity 0. Make sense? It's still moving, what? Although engine failed, but still moving. V is still there. You need to find the location where it reach velocity 0. Then it go down. Right? Then it go down before it hit the ground. You need to find the speed. While in a motion, it tell you to use 9.81 G due to gravity. Ignore effect of resistance. In this case, you know straight away this. What is the value of acceleration? Constant. It give you already. So you can use the equation of motion, the 3 equation there. Okay. So you update your drawing, 40 meter, position B, then velocity 0. This one through your logic on. In final, all this won't be given one. You need to think, hey, what happened to this one and that one. Okay. But anyway, it won't run from all the tutorial question. It won't run out of the what I explained in class. I just changed the subject only. Okay, and before the exam, don't worry, I'll give you some scope to study. For example, I tell you, there will be a question like a rocket question. Somebody throw a ball out, then you analyze. Means that this come out. Okay. Okay, so you go down and then you find the C there. So you need to find this location and what is the distance from the ground. Then find the velocity here. So coordinate system, start level, positive upward. When you go down, it becomes negative. Stick to one definition. If you assume it's going up, then all your solution will be going up positive. So you have early definition, velocity 75 positive because it's going upwards. And you have the velocity here. Your velocity here, so your initial is 40 meter. Because at 40 meter, you start losing power. So it means at 40 meter, your maximum speed is 75. So from here up to here, your velocity drop to 0. So you have two velocity there. So acceleration will be negative because gravity pulling down. The acceleration is negative. Equation to use is use this one. Why? Velocity was given. Acceleration was given. You need to find position. Usually how you apply this one, normally one parameter will be missing in the equation. Okay? You substitute accordingly, you change the equation according to the question. This one become VB, this one become VA, this one copy S, become SB, which is at this location. Because you want to find the velocity at here. Velocity here, you already know. This is the second position. You start from here and here. So you start the last equation minus early equation. VB 0. Although in the question, it do not tell you VB 0. But in logic, you should know when you throw something up, at maximum, there's no velocity there. So this one is 75. This one minus 90, minus 9.81 because gravity pulling down. And the coordinate system is going up positive. Then you calculate, right? SP, you want to find initial 40. So there's only one unknown. You solve, you get one answer. Then velocity, before it hit ground, you focus between B and C because you already know the height from B to C. You already know. So again, you have velocity, you have acceleration, you want to find location. Right? Oh, sorry, you don't know velocity at C. You have missed here, you have this one, you have this one, you have this one, you have this one. One missing there. So substitute value, VB, you already have. VB is what? 0. AC, 9.81. But this one, going down, negative. Right? SC minus 1. You get VC. Again, square, you square root, you have two answers. One positive, one negative. You need to choose whether it's positive or negative. Okay. So in this case, it is going down. Early you go up is positive. Now you go down is negative already. You choose a negative sign. Your answer is negative 80.1 meter per second. Or second answer, you write positive one, but tell the direction. Because velocity is a vector. Velocity is a vector. Vector have magnitude and direction. Okay, makes sense to all of you? Okay, the rest you read. Next lecture, we will go into no more continuous, but is erratic means changing motion. It changed along the way, right? So see you to next week, Thursday. Okay, we stop here. Yeah. Hold on.
In that example.